Okay, so thanks everyone. Today I would like to share this paper in our group meeting, which is called the DFAM, Dynamic Evidence-Based Fact-Checking with Multimodal Experts. And here is going to be the overview of my presentation. So I will start with the background related work and then into the paper's proposed framework, DFAM, and their benchmark, and finally present their empirical results and takeaways and future directions. So first, this is the background about the fact checking. The motivation of this kind of technique is because misinformation is scaling and it is often multimodal. For the misinformation, it can be the AI generated informations nowadays, like those hallucinated information. Yeah. And they can also be those text on the web sources, like those news articles and so on. So there is a technique called the automated fact-checking systems that's been developed fast these years. And here is a brief framework about how it works. So it is an end-to-end verification for text and potentially the image claims using retrieved multimodal evidence with an explainable report. For example, if we have let's say a paragraph, then this kind of AFC system can break them into the claims and detect each claims based on its evidence retrieval. Like it can retrieve from lots of places, which we will see some examples today. And then they will generate a report to say like for each atomic claim, whether this is true or false. And some optionally they can have a justification here. And here is one kind of categories about the classification, which people call it verdict classes. So here are four classes like refuted, which means the claim is considered refused when the evidence contradicts with the claim. Second, the supported, which indicates the claim is accurate based on the evidence. Third, the misleading, which means the claim is misleading or require additional context. And finally, NEI, like not efficient information, which means the claim does not have enough information to be verified. And this series of work developed for a long range of time. They first start with the text-only fact checking. And here are some of the related works from like 2017 to 2024 and how it works. So here is an example. Let's say we have an atomic claim, not fully atomic, like Biden disappears in some of the states on 11th November 2020. So when an FAC system want to check whether this is true, it can like break those four states into four sub questions. And for each of the question, they will check the news, like those popular news platform in the or media platform, like in the United States, to check if this kind of claim is correct. So they will check which media project Biden will win in Nevada, Arizona, Georgia, Pencil, uh, Pennsylvania, yes. And they find that in some of the newses, especially question one and question four, I guess, many media platform predicts Biden will win, which conflict with the claim. So the verdict is going to be refuted. And the justification is that many media organizations believe Biden will win in those states. And here we come to the multimodal fact checking because most of the data are multimodal or like even those text only data, they require the multimodal evidence retrieval. So this is the motivation of why these kind of things appear. And here is the example that I bring from one of the benchmark data set in the multimodal fact checking. On the left half, the paper calls it the multimodal information. So, for example, they have two cases. One, this case, which is called the cross-modal relation. So the photo shown here is paired with a potentially false caption about, let's see, the image shows the ground covered with the garbage after da da da. So something here may be wrong. So the caption paired with the images is wrong, and this is a false claim. And second, they have the both the cross-modal relation and the manipulated images. For example, here the image itself is manipulated, and the caption here this even it describes this image like the photography shows a flooded runway at Northwest Florida, but this is still a, let's say, a false claim. Yes, and the paper also categorized two other cases on the right half, which contrast this with the asymmetric multimodal information. So this mostly means like the falsehood is carried by one modality and the other modality just suppose it loosely rather than forming a precise factual image text relation. And this case is an associative image, like the text claim is false. There are um, 53,000 dead people turn up on the state's voter in the November 2018. But like in the images, it's not that people, right? The quantity is wrong, and those are live people. And in the case D, it's called the reinforcing caption, which means the manipulated image in the mean is a misleading element. So the caption simply reinforces what the image suggests, and this also counts as the one of the problematic scenario. And here should be a first paper that worked with the multimodal large language model to perform the fact checking, which is a prompt-driven solution provided by the MLLM. And let's see how it works. So it basically has a claim, like we say before, and with an image context. And the goal is that the fact-checking system want to predict whether this is a supported or unsupported or like insufficient evidence claim based on the existing context. So yes, let me remind myself. I guess in this paper they are trying to retrieve some kind of multimodal information using RAG. So they have a chain of the RAG and tree of the RAG in the paper. So for chain of the RAG, it means like we ask one question, then we retrieve the evidence, answer it, then use the accumulated QA history to decide whether another follow-up question is needed. And if it's needed, we sequentially like ask those questions and retrieve the related information using the RAG. So that's the chain of the RAG. And also they have the tree of the RAG, which means like at each step, they generate several candidate questions, retrieved all of the questions from these three, or like several questions, and determine if the QA is correct. So they will have the retrieved based on the RAG. Then they prompt the multimodal large language model, which is the GPT-4 at that time. This paper is from the 2023, so they use the GPT-4 and GPT-4V based on their evidence, their retrieved evidence and the image captions. So finally, they have this uh, velocity prediction and the explanation. So this is the very first work working in the multimodal domain. However, like there are many challenges still in the multimodal fact checking. Those are something I listed like the out of the context reuse. So out of the context means that the content itself is not altered because we see there are manipulated images before, right? But it's present with the wrong surrounding context. It's more like the things are not paired, which makes the things misleading. And also like they have the misleading captions or partial status. The third point is one of the focus nowadays. So people want to have the multi-hop evidence gathering and also multi-hop reasoning process, which we will see it in the future directions. And fourth, there is a temporal drift. This is also an interesting scenario. Like, for example, if we use ChatGPT to perform this factual verification, then there's an experiment we are going to say that for data sets that's before the GPT is developed, it's of good performance. But this is not the case for the new articles and informations. So there's a temporal drift. And also the explainability, which we say before, if we have a reasoning process there, that will be better. So the motivation of this paper is that the prior automatic fact verification methods often cover parts of the pipeline or only in the text domain, which we said before. And one motivation I forget to put it here is the temporal drift. Like most of the benchmark datasets are developed uh, in those old years we said before, right? So they maybe with those modern models, they are actually short in the fact checking. But because they have the prior knowledge, they check the past benchmark well. So this is also why this paper want to create a new data set. So this DFIM paper aims to unify multimodal claims, multimodal evidence, evidence retrieval, multi-hop planning tools. So it's an agentic system, reasoning explainable, and it's training free, open domain, and open source. So this is the overview of this paper. Oh, okay. So here is the detailed contribution. So it proposes a modular zero-shot pipeline for the open domain text image claim verification. And it uses the dynamic planning in its agent system, like it will dynamically select the tools, search depths per claim. And it will also handle the multimodal claims and multimodal evidence end to end. It will produce the structured, human-friendly, explainable reports. And also like it proposes a new benchmark called the Claim Review 2024 that tests the temporal generalization of the existing baselines and itself. It has a strong results, which we will see compared to the baselines. So here is the overview of the framework. It has mainly three components, which we can see. The first one is the multimodal LLM, where it will be responsible for the planning, summarize, develop, judge, and justify. So it's in the red box here. And second, it has a suite of multimodal tools. In this paper, they emphasize four tools, which are web search, image search, the reverse image search, and the geolocation. Oh, sorry. And finally, they have this kind of third part, which is their report part, because they want to make the overall verification explainable. So they have the claim, actions, evidence, exploration, verdict, and justification. The category of those verdicts they use are the things that I introduced before. Those are supported, conflicting, refuted, and NEI. So here is its overview. Let me see. Hopefully this is the correct slide. Uh, Basically, the input of the system is the claim which contains the images and a potential caption. It's just a text claim. So it will first, let's say, use those vanilla baseline like GPT-4o optionally with the chain of the thought to to judge if this kind of claim is correct or not. And then they will have their new proposed framework to have their justification and the verdict. So this is the overview of the study. And DFIM contains six stages. Here I will go over them one by one. First is the stage one, the applying actions, which is initialized by the multimodal large language model. So upon receiving a claim, the MLLM is prompted to suggest a target action sequence to retrieve the missing information. And this planner aims to minimize the action and the cost. How they implement this is that they use the in-context learning, which guides the modular in deciding which of the specialized tools to invoke, like those four tools we see before. And after they get that trajectory for using the tools and performing the rest of the things, here is how they are going to execute those four kind of tools. The first one is the web search, which basically given a query and they use the Google API to search the relevant web pages. In their implementation, they will retrieve the top three relevant web pages that matches the query. Then also the image search, which also given the query, they try to use the Google API to retrieve the top three relevant images. And here is the reverse image search, which means for the images either in the query or in the process, in the trajectory of the search, they can retrieve the URLs of that specific images. For example, giving an image, it's either coming from the query itself or it's from the image search tool. Then this reverse image search will retrieve the text content, like the web page containing that kind of the images. And they also introduce this geolocation tool, which is the geoclip to estimate the most probable country the image could originate. And stage three is for summarizing the results. So in this stage, the model basically like generate an abstractive summary of key findings for each tool output, ensuring brevity and alignment with the existing report. And the relevant images are retrieved and incorporated, while the irrelevant results are filtered by the MLLM. And here comes to the stage four, which they use the existing retrieved information before to develop the fact checked. Basically, the framework directs the MLLM to discuss the claim's veracity step by step, but based on the previous evidence, and flag any gaps as incomplete if the information is missing. So it's here like so next, after we have the previous report, the framework can classify the claim into one of these categories. So support, conflicting, refuted, and NEI. If it is not efficient information, then the system will loop back to the stage one to retrieve the additional evidence. And this process will proceed to the final stage once a definitive verdict is reached or three iterations have been completed. So they have a back loop here. And finally, like after they gain all of the information, they will generate this kind of report. It's basically adjust for human readability and explainability, which they will adjust the length and make the report to be concise and clean. Okay, so this is their fact verification framework. Next is most about their dataset and benchmark. Because we mentioned before, right? They think the existing benchmark, even for multimodal domain, they contain some information that those large language model has been trained on. So they claim that there's no current dataset supporting the evaluation of MLLM factual tracking. And this is the motivation they want to create this claim review 2024 plus. In this dataset, it contains a set of 300 English claims from Google Fact Check Claim Search API. So they are building this claim from this API and also perform the human validation. Those articles are collected from the period between the November 2023 and January 2025. So their focus model is GPT-4o, which is developed before the November 2023. And here are some examples of their claim. Yes, by the way, they perform the human annotation, like labels are annotated by the PhD level AFC researcher, and the overall data set is validated by another annotator by comparing all of the instances with the original fact-checking articles. So here are some informations. We can pick some cases and look at them. For example, here's the report supported case where a Russia textbook claiming former US President Donald Trump lost the 2020 presidential election due to voter fraud, which is the correct case, and it's matched with this newspaper, I guess, or the Russia textbook. Yeah. And let's see, another information is the refuted information here. So the image says 97% of all guns are in the red territory, and 97 of all gun violence is in the blue. But the claim is that the map shows areas of the United States with high rates of gun violence vs areas of the map with high rates of gun ownership. I guess the problem is that the map is not showing clearly with the gun violence, right? It's just a text. And it's also possible that the image is being manipulated, which I'm not sure. Yeah. And also they have the NEI case here. It's basically a claim. In 2020, Trump said to two people in a private conversation at the White House, I need the kind of generals and Hilton had. And this information is, of course, like we cannot verify it because it's not supposed to appear in the public social media. And here are, so they test their framework in their own benchmark as well as some existing benchmark. And here is the first empirical takeaway, the overall performance. And the takeaway is clear, like their framework achieves the state-of-the-art results on the standard and self-curated benchmark. So this is basically a takeaway. And they start to analysis like based on those four categories, what's happening in their baseline GPT-4o and GPT-4o chain of the thought with their cases. So first for the baselines, this is the heat map, like the rows shows the actual label and those columns shows the predicted label. And here those um, green cells are cells that represent the correct cases, and the red cells are those being predicted wrongly. So pure GPT-4o overpredicts the um, NEI. As we can see, like most of the cells here are red, but it still outperforms the COT counterpart, which means like COT counterpart is also very bad. They have the strong prior to predict there's no sufficient information. And also the COT counterpart shows a stronger tendency to commit to the misleading. And I guess this is just because the language model prior itself, it tends to say, hey, this information is misleading. But after adjusting to their framework, like we can say the confusion matrix is more balanced. Most of the cases is correct now. And for each category, they are not like overweighted, overwrongly into one kind of category. So they want to claim like their algorithm will be better here. And next is that they try to perform the ablations in two perspectives. The first perspective is about these four rules, is about those two ablations. So they try to evaluate the contribution of each of the four tools by individually removing them from the pool. And as we can see for this data set, right, and the first data set and the third data set, after removing the web search, the performance drops dramatically. So web search is very important for both for first and third data set, when the reverse image search is important for their own curated data set. And also a takeaway is that this framework also benefits from all of the tools. The second ablation ablates the configs. It's basically the four lines here, and I will explain them one to one. First, the singleton. So in this version, the framework is restricted to pass all stages only once, so it has no ability to dive deeper into the findings. That means by the singleton, and we can say like the performance drops dramatically, which is expected because usually we want to do the double check. And second is about their framework, the agentic framework, like without planning. So in this variant, it tries to fix all actions into a static action schedule and each tool is executed exactly once, bypassing those dynamic planning stage. And in this version, the performance slightly drops for the first and third data set, but it maintains relatively well, which means like this step is important, but it's not dominate the performance. And the third case is that without the develop stage. So in this case, the question is basically, is the intermediate reasoning useful? And this variant excludes the develop stage, like the intermediate reasoning. So it jumps from the evidence retrieval immediately to the judgment, which is in our previous slide, actually. So we can see like in this case, the performance drops a bit. So it's not all dominant, but it still drops a bit. And finally, like they tried the unimodal develop stage. So they wonder if the textual reasoning is sufficient here. And this part, like the unimodal variant can retrieve evidence images, but cannot pass them onto the future stages. And we can see like the performance also drops a bit, but not dominant. So the takeaway is that the single term plays the important role and all of the rest helps. Uh, okay, so finally, they have some failure case analysis, like when will this verification system fail? One is the label ambiguity. So they find the framework mixes up similar labels, like refuted and misleading sometimes. So this is, I guess, the internal like limitation of this study. And also like they have a missed evidence failure case analysis. This is also a general limitation of the factual checking system. It's basically after the framework, it hosts all three retrieval attempts, but it can still not find the enough evidence. And indeed, like some evidence for the dataset are hard to find. So here is the case, like the image shows the crowd of people at the area of 15-1 right in the September 2019. But just from looking at the image alone, or like even after performing searching in Google with this image, they find no evidence here. So this is a general limitation of the factual checking framework. And also like they find there can be reasoning errors in the process, which are mistakes that happen during the natural language inference, which is intuitive. And finally, they have a premature judgment. So this happens when the framework commits to the verdict results before gathering the sufficient evidence. So the evidence is present in the knowledge base, but unfortunately, the framework missed that before they make the final decision. So here's the takeaway of the overall study. This study first find the agentic retrieval matters, and they think that the fact checking improves when the model searches for fresh evidence instead of relying only on the internal knowledge. And second, they think the multimodal evidence helps, where this framework uses the text and image evidence as well as tools like web and image search. And third, like they they think like the strong fact checking need to use the tools, evidence grounding, explanation, not just the better prompting. So this is the motivation they construct this framework. And another thing from the failure case analysis is that we still say the quality depends on the retrieved sources and can fail if the evidence is misleading or misleading. So this brings to the future directions of the fact-checking, this series of studies. One is that people may need to consider extending the tools and external knowledge bases to support more evidences, because evidence is important for the verification. And this is one of the study like preprint posted this year. And we can see that one of the major contribution is that they try to add different kinds of knowledge, different kinds of knowledge. Yeah, the publisher identification, those academic articles, and many things. And the second research direction is to optimize the overall agentic pipeline to efficiently leverage the existing knowledge. And this is also represented in this follow-up study, where they try to have, for example, the claim normalization, all of these more fine-grained actions. And thanks everyone. This is my presentation today.